Hey everyone, welcome back. This is the last and the third lecture on Java Collections Framework, wherein we are seeing the second category of collections, which is the map implementations. Okay, some demos, some examples. If you want to learn more about the fundamentals, please go ahead and watch this collection framework video, part one. All right, let's jump right in. As you remember from the previous lecture, that at the top of this is the map interface. This framework, collection framework, is the map interface, which there are three classes. There are multiple, but basically there are three classes: HashTable, HashMap, and TreeMap, which implement this interface. Each has their own characteristics and own use cases. So let's see when we are going to use which one, or when should we use which one. They all belong to the util package, java.util. All right, let's see the first one, hash table. It is one of the oldest implementations. Unique feature about hash table is that it is thread safe. It is synchronized and thread safe, which means if multiple threads are trying to access the same collection and update it, you will not get concurrent modification exceptions. But since it is synchronized, it is slow. It has a performance overhead. That is why it is not used so widely. It's better to manage your own synchronization than to have the collection object manage itself. Some methods, since it's a key value, like how in collections like list, arrays, it was add method. Here it's a put, wherein you specify two arguments. The first one is the key, and the second, the value that corresponds to the key. So when we try to retrieve the value giving the key, it gives the value which is associated. So in this particular line, when you do sys out, it will obviously print 1, right? Because ONE, the string spelling of 1. One cool tip, maybe you already know or maybe you not, but a cool tip in IntelliJ is if you want to write system.out.println, you just say s out and press tab. It's a shortcut, okay, of writing system.out.println. Thought I could share it with you. It's in IntelliJ. All right, some other methods. Now these methods, entry set and values and key sets, they are also applicable to hash map. Okay, this is hash table. Hash map also has these values, but there are some additional ones which we're going to look at it a little later. Now get an entry set, and an entry is nothing but a key value pair. Okay, if you see here, entry, it's a key value. Okay, what is the C map.entry? And entry consists of what? Integer and a string. And why does it contain an integer and a string? Because we defined it as an integer and a string. So whatever you have used it, when creating the instance, it will use the same, it will return the same values. So it has two methods, get key and get value, because it's an entry in the map, okay, or in the table. So from the entry, you can get key and you can get a value. So each represents one entry in the hash table or hash map. There is a method which can retrieve all values. It will just return all values. We'll debug it and see what does all values contain. So in this case, it will contain 1, 2, and 3. So these are some basic functions for hash table. Now for hash map, it's similar functions apply. You create it in the same way, but I have shown an additional way. What is that? You do put all. which takes an instance of another class, which implements the map interface, and it's a hash table here. So here you put all, now this hash map will contain all the entries from this hash table. Okay, and it can be replaced with a parameterized constructor also here. See, IntelliJ gives you a tip. Okay, now here also it can be replaced with map.forEach. A lot of useful tips IntelliJ shares with us. There's this interesting method which is called as merge. What it does is, so let's say there is a value already there. I've given this example. 1 and ONE is already there. You want to update the value. What you do is you call the method merge. So you give the key. Okay, so if this key is here, add it uno to it. But what do you do? So you have to give it a function. Okay, you have to give it a, this is called as a see here, this is called as the remapping function. Yes, so what you're doing is remapping. So what you're doing, telling it is that if 1 already exists and there is a value, apply this function to it, which means it will concatenate 1 and uno, and it will just, we'll see what the output is. And if the value does not exist, what happens is, and if you still call merge function, it acts as if it is adding a new value. So after this, in the hash map, you will have 1, 2, 3, and 4. All right. So till here, let's see it in action. Okay, let's debug this code. Here it is. So first, let's see, before we go ahead, anything. So we are here. Let's see what does our hash table contains. Our hash table contains 3, 2, 1. It's in descending order. Okay. Fetching values here, get 1. If you look at console, fetching value, it's 1. Okay, so that's how you retrieve the value. Entry set, see, get key, 3 is the key to fetch 3, 2, 1. Now, interesting thing to notice, in the hash table, the keys were stored in the reverse order. The values were retrieved in the reverse order. So we added 3 last, but when retrieving, 3 is the first one. And as you can see here, it's in the hash table, the entry set has 3, 2, 1. That's how it is stored. Now, all values is nothing but, it's a collection. So what does it returns? Just the values, 3, 2, 1, right? So this is key value, key value. So all just values will return all the values here. And you can see it's just values. If you would have done a key set, it would have given you a key set, or just these digits, 1, 2, and 3. And now here in the hash map, look at it. In the hash map, did you see the concatenation? 1 and uno, because it exists, it concatenated, it applied this function. Okay, string.concat. And the 4, when we called the merge function, 4 did not exist. So what it did, it just went ahead and added 4 to it. So now our new hash map, this one, has 4 values. So when we see in the size, it will be 4 because there are 4 elements. See, after remapping, key, when the key exists, 1 and uno. Okay? So that's it. Values.size, we are printing it here. Just getting, and what it returns is, it returns collections. Okay, it returns an object of collections. with all strings. Why string? Because again, we have defined it as a string. Okay. Another interesting thing to notice, see, new hash map also contains 1, 2, and 3 because we we just instantiated and added all elements from this hash table into this new hash map, right? So these are some functions which are available for maths. Okay, hash map and hash table very much similar, except that one is synchronized or thread safe, the other is not synchronized or not thread safe, which gives it an advantage of being faster. Hash tables are slow, but hash maps are faster in performance. So this is about hashing. The last class that we're going to talk about today is tree example. So as we said in the beginning, hash table, hash map, and tree map are three different implementations of the map interface. So let's see what is a tree. Now, as we have seen, a tree, there is an algorithms, right, in tree which helps you in sorting. So where the general order is the lower value is on the left, the higher value is on the right. So tree map is a sorted implementation of the map interface. If you do not specify what order to sort the elements, it will sort it based on its natural ordering. What's natural ordering? Like A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. That's natural ordering. Okay. It is a red and black implementation, red black tree implementation. So it's one of the algorithms of sorting, red black tree. Please go ahead and see the videos on this if you don't know what is a red black implementations. So it orders the elements based on their natural ordering, or if you want, you can give a custom comparator. How do you create a tree map? Simple, instantiated using new. Now look here, I have given here, I'm inserting elements in random order. Okay, and now let's see here. Getting the value is similar to the hash table and hash map. You give the key, you get the value, but some other different methods. Now again, adding elements is also same put, right? Like how hash table and hash map had. If you want, you can sort it in descending order. It's again reverse ordering, like from 10, 9, 8, 7, 6, that way. These two are interesting, ceiling entry and floor entry. Now, let's see it in action before talk. Okay, before we go on talking, let's see it in action so it's easier to explain. And comment these out so that right? Okay, all right. Let's debug it and see it in action. All right. Here you are. Now, if you see the tree map, its size is 7. We inserted it in random order. But did you see it automatically inserted it in its natural ordering? 1, 2, 3, 13, it's natural ordering. All right. Now this value should be 2. Key, no big thing. These things are very interesting. Let's see, descending order, what it is. Again, the size doesn't change, but what we are expecting is 100 should be at the top and 1 should be at the bottom. So let's see. Yes, as we expected, 100 is at the top, 1 is at the bottom. Next, ceiling entry. What it does, it returns, see, we do not have 8 here in this, okay? So it will return the next value, which is higher than 8. Now, in our case, the next value higher than 8 is 13. And see, this I am calling it on TreeMap, which is here, which is still in ascending order. Okay, this TreeMap. I'm not calling it in the descending order. So again, it does not change. So I'm expecting this to print 13. If there was an entry of 8, it would have printed 8. So ceiling means higher. Next entry, which is higher than or equal to the given value. Floor entry, the reverse. So see here, floor entry is 5. So what are we doing? We do not have 5. So it will return the next value, next immediate value, which is lesser than 5, which is 3. It will not print 2 and 1. So let's see if it is true. So ceiling entry, see here, it's 13. That's what we expected. Floor entry, we are expecting it to be 5. Oh, sorry, we are expecting it to be 3 because 3 is less than 5. We do not have 5 existing. So that's ceiling and floor opposite. Another interesting is there is submap, just like we had sublist. There is a submap. There is also a tail map, which is interesting. What we give is from 50, like the starting point, and inclusive in the sense whether you want to include 50 or not. Okay. And what do I expect? So if we look at here, it should be, I think it should be 56 and 100. Let's verify. So yes, here, 56 and 100. So it starts from 50, inclusive in the sense, if there was 15, then it would have included it, or it would start from the next element of 50. So this was about tree. Again, it's sorted based on natural ordering. It uses a red and black tree algorithm to sort the methods. It guarantees log n retrieval time of the keys. In order to retrieve a value, you use the method get, just like you used in HashTable and HashMaps. You can sort it in reverse order. There is a descending map inbuilt method. Ceiling entry, floor entry. Give me a map which has keys greater than or equal to this. Okay. And again here, give me floor is opposite. Give me the entry. So see, it's an entry. So it's 1. It's not a map. Okay, so just 1. So the size of these is just 1. So floor means give me the entry which is less than or equal to this. All right. Tail map, again, start from here. Give me inclusive of 50. All right. So this simple code would be there on GitHub. Feel free to go there, download it, update it, add some more methods, and see the changes for yourself. All right. Thank you all for your time. Hopefully, see you all again in the next lecture. Take care. All right, everybody. Bye.